I'm glad you showed lead and not fecal coliform. Well, I congratulate you on a very crisp, very well presented material. I'd like to turn over to the panel of judges. Alice, would you like to start with any questions? Oh, Simon. Simon, start. Okay, Simon.
Okay, let's see if Simon has a question about this. I think you stated that there was a metal pollution in there were some...
Yeah, a common water quality problem?
That's right.
Yeah.
And in your evaluation, when you were trying to compare data from Miami and from South Florida comparing to Havana, why do you, I don't know if you did or you did not, at least it's not in your written proposal, why did you not compare the type of industries that we have here in Miami compared to the one that they are in Havana?
There's two reasons why. First of all, it's, again, because of the uncertainty in Cuba. I mean, there were a couple reports talking about certain factories. I think there's a tire factory and a can factory. We just didn't know exactly what it was in Cuba. And the second thing is that our model focused on non-point source pollution. Industrial areas, like you're talking about, are more indicative of many times point sources, like just direct outfalls from a factory or something.
Were you able to get any information on the existing infrastructure, especially in the urban areas? In other words, is it all direct discharge? Is it a combined system? You know, any idea of what the existing infrastructure is, and is there any treatment whatsoever?
Again, well, as Dr. Solo had mentioned, there's a lot of gray literature out there, and we read through some of it, which did address directly the infrastructure and the wastewater treatment plants, et cetera. But again, we didn't have enough solid information to proceed with that. It was just too much uncertainty and too many unknowns dealing with the infrastructure. And also, this is a runoff model. So we wanted to just consider, urban areas, what kind of pollutants and runoff volumes and concentrations can we consider just from runoff.
So whether the runoff comes from pipe or from across the surface, it's still runoff, right?
Yeah. Essentially, yeah. Yes, sir.
The simulation model is very, very good, and that's the new generation of evaluating engineering problems. With little data, we can actually abstract and extrapolate. The one thing that would be very useful is positioning to what problem actually exists, does it exist, and what's the future cause. In other words, there's a contamination problem. What is the severity, what is the impact either on economic or health terms, and be able to qualify for the population set itself, and what's going to happen if we don't do anything about it, or we did something about it, and factor that into the model.
Well, to piggyback on that, one of the most powerful results of this model is that this is just a relative scale. I mean, looking at this, you can relatively see that if you're going to go remediate someplace, you're not going to focus your efforts here. Exactly. Your first step is going to go right here. So you can go into these upstream areas, and maybe there's a lot of people sick there. Maybe they get a lot of fecal coliform, diarrhea, vomiting, or maybe there's metal content and they have symptoms of stuff like that. So this is a good first step in identifying that.
You have a great tool. What I would do is humanize it and personalize it so that you can derive either a monetary or health value associated with it.
Well, that'll be the team's project for next year.
By the way, an excellent presentation.
Thank you.
Well organized. Obviously, you did some practicing on your time. I need some clarification. You follow through with one parameter in your analysis, which is lead. Mm-hmm. Lead is associated with areas that are more developed.
Right.
However, most of the junctions that had issues are upstream, which is south and east, in areas that are less developed. Any thoughts on the impact of nutrients, which are more associated with those areas?
Yeah, okay. There's two answers to that. First of all, because this is a runoff-based model, the runoff component doesn't change between pollutants. So essentially, this shape you see, even though it might be at different magnitudes for different pollutants, the shape of this plot is going to be the same for all eight pollutants we looked at. Because even though from pollutant to pollutant, the mean and the EMC and the standard deviation, et cetera, would change, but the actual flow doesn't, because the flow is based on land use, which doesn't change between pollutants. So this shape across all 8 pollutants is going to be the same. Okay. The second reason why we picked lead is because let's go back to Matt's table real quick. You can see here some of these don't have water quality standards. Lead happened to be, I believe, the only pollutant we had that had applicable water quality standards and also had parameters we could plug into the USGS model. Because the USGS model only considers, I think, there's only parameters for that for 5 or 6 pollutants. And of the pollutants we were looking at, lead was just good because it fit into the USGS model and also fit into the Florida water quality standards. So that's why we chose lead just for simplicity, consistency.
Just looking at the layout, I would presume that the reservoir is a main source of drinking water for the Havana area, perhaps. And I don't know if you have any data with regard to that and what your analysis would tell you with regard to the safety of drinking water.
Let's go back to the beginning. I want to get the statistic right. That's why I'm going back. Where is it? Here. 47% of the drinking water for the city comes from groundwater, not from the reservoir.
Right.
Okay, right.
So 53%.
Well, 53% comes from other places. It doesn't mean it comes from the reservoir. Yeah. And the other, I mean, just looking at a map, this is such a dominant water body in the whole watershed that we couldn't, you know, come up with a model talking about pollutants up here that get tracked all the way down to the ocean. So we just kind of essentially drew a dividing line here and considered 2 regions, an upper region and a lower region, and then how, you know, modeled how each of these then contribute to the significant downstream water body that they had.
If I may ask, Cristina, is this the Ejército Rebelde?
Yeah.
That you studied also, right? And there's a treatment plant near there. And
The issue is that the reservoir is directly connected to this underground aquifer.
Yeah.
And there's a big concern for contamination of the reservoir.
Right.
Because,
it feeds
you know,
the
that's
groundwater
the
supply.
47% drinking water.
Yeah. Again, our model didn't consider groundwater effects. It was just simply a runoff model. Yeah. See this urban area up here. I mean, correct me if I'm wrong, but that's that Cotorro region, right? Cotorro.
Cotorro, yeah.
Right. So there's a you guys studied some water treatment plants up there in that region, right? Yeah.
And the reason being, it actually coincides with your high levels of contamination
Yeah.
in that region.
Yeah.
There's also a lot of metal industry up in that region.
Yeah.
And by treating that water, we found out that we got the most benefits for the money put in there.
Yeah. Yeah. Did you guys recommend like piping it onto this side of the watershed or something? Wasn't that the wastewater treatment plant? Wasn't it supposed to discharge
In the upper region.
in the upper region?
In Cotorro.
Yeah.
So.
Anything else?
Have a nice round of applause.
Thank you.